program. So here you are supposed to write a program to find the square of a given number between 1 to 10 using lookup table. Using lookup table is the condition given. So first let us write the lookup table, then it is easy to write the code, students. So this is the lookup table what I have taken. So I have taken a starting address as some location says 0x40000. So I have taken the 5 as a given number whose square to be found. You can take any other number also. So if you take 5, then your answer must be what? 5 into 5, 25, right? So I am storing this answer in the another location, say 10. So let us see how to fill this lookup table. So because I don't know, now I have taken number as 5. But here you will be asked to show the answer for any number between 1 to 10. So what is that I am doing initially? For each and every number between 1 to 10, let us have a result of the square of that number from 1 to 10 in these locations that is taken as a lookup table. So this is my lookup table, this memory location, right? So what is square of 1? 1 into 1 is 1. Next square of 2 is 4. Then square of 3 is 9. Square of 4 is 16. Then square of 5 is 25. Square of 6 is 36. Then square of 7 is 49. Then square of 8 is 64. Square of 9 is 81. And square of 10 is 100. So this is how we are initially are supposed to store these values in the lookup table. Then if I give the number as 5, your answer you have to, if it is 5, then you have to jump to the location where you have the answer for 5 as 25, that you have to access and then put it in the result location. Say for example, if I give the number as 9, 9, then you have to jump to the location 81, then get the result here as 81. So that is the declare the directive area, program name as square, then code section, read only. So next step we have entry where you will mark the first instruction to be executed. Then I have a lookup table which I have declared with the starting address 0x4000. So I will initially before you terminate the program, I will what is that memory location I want to go for to store the inputs. Input means this one. So the number whose square to be found as well as the square of the these numbers between 1 to 10 I will be storing in the lookup table. I am using the memory location name as lookup with the starting address of this 0x40000. Same way I want to store the result in the with the starting address of 0x400010, say 25. Same thing, lookup I am using as a memory location to store the input of lookup table. DCD, I think I explained what is DCD in the last class. With the location number, starting address I have given here. Same way result, I am declaring with the DCD as the location number 10. So result is the name of the memory location where I am going to store the result, and lookup is the name of the memory location where I am going to store the inputs. How many locations you have here? First location to have the number whose square to be found, the next 9 location to store the square of this, something like that. Let us see. So what is that you are supposed to do? First let us see. Let me load. Load instruction is executed here. Load register R0 with lookup. That means what? What is lookup is pointing to? Lookup is pointing to this memory location address. So this starting address is loaded to which register now? R0. Indirectly, R0 is used as a pointer to this memory location, right? Now, same way I want to use R2 as a pointer to the memory location result. So what is that I will do? Load the register R2 with the result. That means what actually it does? It will load the starting address of the result. What is the address I have? 0x40010 to R2. That means what? R2 is pointing to my memory location 10 where I am going to store the result, right? Now, so where is my R0 pointing? R0 is pointing to the address 0x400 location. That is what? Here. In this example, I have taken 5. I can check for any number. So for this example, if I take 5 as a content of the memory location 0x400 pointed by R0, that content I will access it now. That content I will put it to R1. Load register byte, because byte only you are taking, right? 8 bits. How many bits you have? 5 is a 8 bit. 05 you can take here. So that one from where you are loading it. This is what content of R0. Content of R0 is 5 now. That will be loaded to R1. Now what is my R1 now? The R1 is holding what? 5 now. So now if this is the case, how many locations you need to jump here? That's square of 5 is stored in which location? 5. See, you have to jump one time you have to jump here, then second time, third time, fourth time, fifth time. So 5 jump you have to do. For that, what is it I will do? Then which location you want to jump? You add that you can add it here. Now, what is the next step I am doing? Add R0, R0 by R1. I want to increase my pointer to plus 5 now. Memory location is pointing to 0, 0. I want to jump it to now 0, 0, 0, 5 here. Fine. So, what is it I have done now? So, I will add R0, R1. What is there in my R0? R0 is what? R0 is pointing to what? Which address? This one, 0x400. Now I will add. This is content of R0 is 5, but whenever you use without bracket, with bracket means inside the location whatever you have. Whenever you don't use bracket, that means what? Whatever the memory location you have already stored, right? Already loaded. R0 is already loaded with the starting address. Now I am going to add the starting address whatever is available in R0. I will add the starting address with R1. What is there in my R1? R1, I have a content of R0. What is the content of R0 was 5, which was loaded to R1. R1 value, R1 data is 5. R0 data is my 0x40001. Now, add 5 to this. So, this will become 0x400000. Last digit is 5. So, my R0 is pointing to which location now? 0x40005. That means, now I have come to this location. Right. Now, what is that I will do next step? Now, I want the result, right? Now, R0 is pointing to the location where you have the square of the 5 as 25. Now, my content of R0 is nothing but the content of this memory location 0x40005, which is nothing but 25. That is loaded. Whenever you use bracket, that means content. That is loaded to which register? R3. So, what is there in my R3 now? R3 is having a square of the number which is 5. For this example, square of 5, which is 25, is available at R3 now. Now I want to store it in the memory location result. So what is that I will do in the next step? Yeah, I have the content of R3 as what? 25. That I want to put it in the memory location result. So what is that I will execute now? Next step, store instruction. Store byte, store the register R3 with the content, whatever you have the content R3 no. The content of R3 should be stored as a content of R2 now. So what is there in my R3? R3 is holding 25 now. 25 is stored as a content in R2. Where is my R2? R2 is pointing to result, right? R2 is already loaded with the starting address of the result, which is nothing but 0x400010. So now the result of R3, 25 is loaded as a content of R2. Content of R2 means content of memory location pointed by R2 as 0x400010. So what is the result you have got? In this location, you have stored the square of the number from R3 to R2, that is 25 now. So done, job is done here. Now you can stop the execution at this stage. Here we are indicated the stop of the execution, and these steps I have already explained, then the termination of the program. So this is say for example 5. So if at all, if I put some of the numbers say 3 here, then how many jumps you have to do? 1, 2, 3. The answer should be 9, right? That time, see here, whenever initially, if your number is 3, how is that the flow will go here? As usual, R0 will point to the starting address of this, R2 will point to the starting address of the result. But this time, content of R0 is loaded to R1, means this time, what is this location you have here? This location you are storing 3, you assume. 3 is going to be taken as a content of R0, that is loaded to R1. So content of R1 is 3 now. Now I will add R0 and R0 plus R1 and result I will store it in R0 itself. What is there in my R0? R0 is content means whatever the data is available inside the location. Now I have not this bracket here. That means what? R0 pointing to this address 0x4000. Now I will add the 0x400 to which one? R1. What is my R1? R1 is holding the data of R0, which is 3, right? R0 was initially pointing this. Here I have 3. That is available in R1 now. 3 plus R0, whose memory location value is 0x4000. That means what now? When you added 3, the address will become 0x400003 now. So where it is available? Again, it is available in R0. Indirectly, now R0 is pointing to which location? 0x40003. So now you have come to this location where you have 9, right? Now, so whenever you load the content of R0 to R3, this time, where is your R0 pointing? R0 is pointing to the location of 0x40003 where you have 9. So content of R0 is nothing but 9 now. 9 is going to be loaded to which register? R3. Now next step, store the result of R3 in byte into which content? As a content of R. Where is my R2 pointing? R2 is pointing to result. So result location number is 0x400. So whatever the 9 you have in R3, that you are going to load it as a content of R2 pointing to the memory location 0x40010, which is this time 9. So that is